Good morning. This lesson is for my Integrated 1 class. This is lesson 12 for Unit 7. Before I get started, I want to say that I hope everyone is doing okay out there. Let's keep doing our assignments. Let's put ourselves in a good position when this quarantine is over that we can argue, hey, I've done everything that you asked. I should get credit. So let's just please make sure we're doing everything that I ask. And also, let's keep taking attendance. Just take that attendance quiz. It shouldn't take you more than 20-30 seconds to do. And let's make sure that we, when this is all said and done, that we we can be proud of how we handled this quarantine and, be better on the other side of it. So I want to talk about our goals today. Our goals deal with geometry, and I really like geometry because it's a different type of mathematics compared to the algebra side. The algebra side, you're solving equations, you're graphing lines. But when it comes to geometry is interesting to me because it's about logic. And logic, it's like these mind teaser puzzles. You figure out what must be true based on what you know. And I really do enjoy this type of thought. And so let me get into this, and I want to stress the fact that we're going to understand something and we're going to take that to another step. What must that imply? What can we get out of that result, right? So the first thing we're going to do is we're going to discuss congruent shapes and what that implies. And then the second thing we're going to do is we're going to talk about an introduction to congruent statements and how to use. So again, geometry is a completely different animal than algebra, and I sincerely believe that they need to be taught in different ways. Now, I'm starting this lesson off discussing congruent shapes and what that implies. And so I'd like to just take a second and remind you what it means to be congruent. Now, congruent has to be about shapes. Equations can't be congruent because equations can't have the same shape. They can make the same shape on a graph, so I guess maybe you can argue that. But we're talking about triangles, quadrilaterals, pentagons, angles, segments. We're talking about shape. So congruent to us means, and I can use a word or I can use a symbol, and the symbol's made up of two parts. And congruent means to us that we have the same shape and the same size. The top part of the congruent symbol is what's called a tilde, and that implies that we have the same shape. The other part of the congruent symbol is the equal sign, and that means it's the same size. So congruent literally means the same shape, that's the same size. And if we have shapes that are the same size and they're the same shape, that actually implies something. And it reminds me of cars. I had my car when I was younger was hit by my neighbor, and the driver's side door was damaged. And because all cars from this certain year were identical, what that meant was parts were interchangeable. So the driver's side door for my truck was the same as the driver's side door for another truck made in the same year, the same model. So my neighbor, what he actually did was he used the fact that my trucks were the same size and same shape as other trucks made that year, and he actually purchased another driver's side door because they're interchangeable, they're identical. So if you have identical cars, the parts that make those cars are identical. So you can interchange them, right? And so this is what I'm talking about, what congruent shapes do. They imply something. So if the shapes as a whole are identical, then what that means is the parts that make up the shapes themselves must also be identical. And so this is what I'm talking about when we go, we can go a step further. We can reach a logical conclusion. We can argue that, like, these are identical as a whole, so the parts themselves must be identical. So we can even go a little bit further with our understanding of what shapes that are identical imply. So parts that are in the same position themselves must also be identical. And so I have this example I like to do. Let's say my hands are congruent. They're not, but let's just say for the sake of this example, that I have identical hands. My left hand is the same size as my right hand. They're mirror images of each other, they're reflections of each other right now. But let's say that I have identical hands. And so what that means is that parts of my hands that are in the same positions, they themselves must be identical. So the concept of identical hands means that the parts of my hands must be identical. And the parts of my hands, they're going to be identical if they're in the same position, they're next to the same things. So my index fingers must be identical because they're parts of my identical hands. And my index fingers are next to my thumbs, and they're next to my middle fingers. So my index fingers themselves must be identical because they are in the same position, so they must be identical. This is a very important concept in geometry. This idea of being in the same position is called corresponding. All right, so corresponding means in the same position or next to the same things. Again, my index fingers are next to the same thing. I'm not going to show the middle finger. This is a recording, and I really like my job. But anyways, you get the idea. They're next to the same thing. And so what we're going to do with this section about geometry is we're going to investigate a very simple shape. We're going to talk about a triangle or triangles. So we have 3 sides and 3 angles. Not many ingredients. And so what we're going to do is we're going to focus on first determining if the shapes themselves are identical. And right now we have a pathway to argue that they're identical, meaning that, if we can do a sequence of rigid transformations where one triangle lands perfectly on top of the other triangle, we can say that those triangles themselves must be congruent. So we have a way to determine if triangles are congruent. And so the next piece of the puzzle is, once we've determined that the shapes themselves are congruent, what does that mean that we can get from that? And so once we know that we have identical triangles, what we're going to now focus on is we're going to focus on parts in the same position or they're next to the same thing. And this is a very long explanation concept, but it's pretty easy to abbreviate. So this idea of having identical triangles means that corresponding parts of congruent triangles are congruent. Or we can just abbreviate it and say CPCTC, corresponding parts of congruent triangles are congruent. What this is literally saying, the simplified version of this, identical shapes mean that parts in the same position must be identical. Okay, so again, my hands are identical, then my index fingers must be identical because they're next to the same thing. I'm not going to do the middle finger, I keep catching myself. Anyways, that's the first goal, discuss congruent shapes and what that implies. If I have identical shapes, then the parts that are in the same position must themselves be identical. Okay, so I'm going to check off goal number 1. Now I'm going to start talking about goal number 2, an introduction to congruent statements and how to use. So remember, we're only talking about triangles here. Okay? We're only talking about triangles. So, let's suppose that we used a sequence of rigid transformations and one triangle landed perfectly on top of the other triangle. And we can then say that the 2 triangles themselves must be congruent. And so what we're going to do is we're going to write something called a congruent statement. And I'm going to give you an example of a congruent statement. Okay, I'm going to say something like triangle ABC is congruent to triangle RTS. I'm not going to include the shape because remember this section is on how to use a congruent statement, and this is a congruent statement. All right, so I'm leaving out the part where we've showed that one triangle through a sequence of rigid transformations lands perfectly on the other triangle, and that means that the 2 triangles themselves must be congruent. Now, I'm going to talk a little bit later on how to set these up. Okay, this takes a little practice to set up, but I want to discuss how to use today. All right, so remember, triangles are made up of two parts. Triangles are made up of angles and sides. And since we know that the shapes themselves are identical as a whole, what that means is their parts must be identical. And it's very easy to figure this out. All right, so let's talk about the angles of the triangle. All right, so now I'm going to talk about the parts. I know the holes are identical, so let's talk about the parts. So I know that angle A must be the same as angle R. So I can very quickly write the following congruence, or I can make it as an equation. But my first angle is the same as that angle. I can say that my second angle is the same as that angle. So I can also say that angle B is congruent to angle T. And finally, I can say that angle C, my third letter, is congruent to angle S, my third letter in the other triangle. Okay? So, remember, these guys are going to be congruent because they're in the same position. Remember, parts in the same position of identical shapes themselves must be identical. So the next thing I'm going to talk about is the sides of my triangle. Okay? So, sides have endpoints. And so I can say that side AB must be the same as side RT. The first two letters are the same as the second two letters. Okay? I can say my second and third letter, which represents the endpoints of a side, BC, that must be the same as side TS. And the last side, remember, I have three angles and three sides. We don't have very many parts to triangles. And this is why I like these lessons, because we're not using very complicated concepts. Okay? Triangles, three sides, three angles. So I'm going to wrap around. I'm going to say side CA. That must be the same as side SR. All right, so I'm asking you guys in the homework to take this and write this out. All right, this is how we use congruent statements. This whole thing right here is us using the congruent statements. It's us listing who the corresponding congruent parts are. I know who must be the same because I know who the same is as the entire objects themselves. So this is the entire objects themselves. These are the parts in the same position. These are the corresponding parts. This whole thing right here, this whole thing right here, this is corresponding parts of congruent triangles are congruent. This whole thing is this. We get all of this knowing this, okay? And so that's what I want us to be able to do, is I want us to be able to list all of this today. Okay, so I think that it's a pretty simple lesson here, and then we'll start using this when we get back from spring break. Oh, it's spring break next week. So this is a nice simple assignment. Again, remember we're talking about shapes as a whole, and if shapes are identical, then the parts that make up the shapes themselves must be identical. And yeah, so this is it. So let's again make sure we're turning in the assignments. I've had a couple of you, I'm thrilled to say I've seen your grades go from F's to D's, D's to C's. We're bringing them up, so let's keep up that good work. Let's make sure we're doing the attendance. Let's make sure that when this is all said and done, we're in a better position than we were when we left. And again, if anybody's having an issue out there where you need extra time or you're having problems doing the assignments, just let me know. I want to be flexible. I want to accommodate you guys. I want you to be successful. But if you're not making the effort or you're not reaching out, I can't help you. You have to let me know how I can help you guys. So this is the last video for this week. I will enjoy my spring break. I hope you guys enjoy yours as well. And I will post a video when we get back. Real simple assignment. Hey, let's do it and get the points. Have a good spring break, everybody.